Well, a good question is if we could do that about the y-axis, could we do it about the x-axis? And well, yes, absolutely we can. Here's an example. This time we've got the curve y equals square root of 4 minus x. And we want to take the area that is bound in the first quadrant and rotate it about the x-axis. So when we say the first quadrant, that means that we're going to go along the x-axis from 0 to 4, right? There we go. So that's in the first quadrant. Of course, along the y-axis, let's see what happens at 0. This is going to be 2 up here. So we're going to go 0 to 2. So let's see what's going to happen. If we're going to form shells by going in the about the x-axis, that means that this guy right here is going to be rotated. Okay, so that means it has to be dy. So right now our function is not in a good form, right? If we rotate a curve about the x-axis, we must use dy rectangles, and we're going to obtain something like 2 pi times the integral from a to b, whatever those limits are, of y, representing our radius, times gy, representing our height, right, of our shell, times dy, which is our thickness. Okay, so let's see. We need to rewrite this. We've got y is equal to the square root of 4 minus x. So we solve for x by squaring y. Since we're in the first quadrant, we don't need to consider a positive or a negative case, right? But we definitely know that we're going to get x. Let's try that again. X is going to equal 4 minus y squared. So there's our function. Okay, so let's see. How is this going to work out? For our volume, keeping all of this in mind, our volume, using our formula above right here, is going to be 2 pi times the integral. Let's see, in the y direction, we're going to go from 0 to 2. And we're going to take y, because y is our radius distance right here. So our radius is y. We're going to take y times the function, which is the height of this. So it's going to be 4 minus y squared times dy. There we go. Okay, so rewriting this a little bit, not too shabby here. 2 pi integral from 0 to 2 of 4y minus y cubed. Boy, this looks kind of familiar, except it's y instead of x. Dy, let's see what's going to happen anyways. Our volume, when we work out our formula, our integral right here, we're going to have 2 pi times, let's see, it's going to be 4 halves y squared minus 1/4 y to the 4th. And we're evaluating that from 0 to 2 this time. So a little fancy arithmetic is going to give us our answer, it looks like. So 2 times 2 squared, that's going to be 8, minus 1/4 of 2 to the 4th. That's going to be 1/4 of 16. So that's going to be 4 minus 2 times 0 minus 1/4 of 0 is 0. So we're going to get 8 minus 4, 4 times 2, that's going to be 8 pi as our volume right here. Well, there we go. Right? It's a nice simple method if we know how to set it up.